This is section 223. We're still in the transformation of parent graphs, and we're going to examine the reflection of graphs. So we're going to reflect standard form functions and examine what an even and odd function is. So we already examined the types of reflections, and we're just going to review it real quick. To reflect about the x-axis, we're going to have a negative in front of our function. So our a value is going to be negative. And as you can see in that parabola, when it's positive here, faces up. When it's negative, it now faces down. Now we could also reflect about the y-axis, and we're not going to be doing too much of this, but I just wanted to mention it. The idea of if you have a negative in front of your input, it's actually, if we look at this, it's going to reflect in the other direction about the y. And so if we have a negative in front of our input, that tells us that there's a reflection about the y-axis, but we're mainly just going to focus on a reflection about the x. So let's look at this example here. So I know that there's a reflection about the x-axis. I know that there's a horizontal shift. It's going to move over 2 spaces, and it's going to move down 1. One thing that I like to do is I like to think about what the parent graph is. So that's what my parent graph would look like for a radical function. But now if that reflects over the x-axis, that's now the shape. It's going to reflect over it. And so I just need to keep that shape in my head, move it over 2 spaces, down 1. And so there's the point. And then from there, I have my graph. So I drew in the reflection, imagined it, and so I knew what shape it's going to be. So let's try another one. So I know this one's cubic, and so cubic parent graph looks like this. Okay, well there's a negative in front, so I know that it's going to be a reflection over the x. I know it's going to move over 3 spaces and down 2. So this is going to move over 3 spaces, and it's going to move down 2, which is here. But the reflection, right, this part right here, this is going to get reflected downward. So I can just do a sketch of that just to kind of help. And then this one is going to get reflected upward. So it reflects over the x. And so that orange shape, that's what I'm going to draw in here. And so there's my cubic function. Now it's not perfect, but it's the sketch that matters. It's visualizing. That's what matters right now. Let's look at one more. Let's look at a cubic. Let's look at an exponential. So I have the negative, so that means a reflection over the x. The horizontal shift, it's going to move over 4 spaces, and it's going to move down 1. So I know that's my starting point, and I have that horizontal asymptote, and then my graph is going to do this. That right there, that's my parent graph. But I have a reflection. So that parent graph is actually going to get reflected down. So this, everything gets reflected over that line. Imagine like you fold, if this was a crease right here, and you fold over that crease, like visualizing what that graph would be, it would look something like that. And as you can see, they almost look like they'd fold up perfectly. Now it's that red shape, that's what's getting translated. So it's going to move over 4 spaces, 1, 2, 3, 4, and down 1. Now my asymptote is also going to get transferred down 1 space. And so the purple is my graph. So now that we kind of examined the reflection, now we're going to kind of move over to even and odd functions. Now, if it has a reflection about the y-axis, we actually say, like if the graph naturally has that symmetry and it's symmetric about that y-axis, we would say that it's going to be even. And so this definition here, that's the definition for even. And then this definition right here, we call that that's odd. And so if it's symmetric about the origin, which is actually a reflection of, or a symmetry about both the x and the y simultaneously, we're going to say that that function is odd. Now, the way that we can examine if a function is even or odd is we just use the definition. So if I have f of negative x equals f of x, I have to show if that's true. Now let me clean that up. Right, and it says it right here. That's my even function. There's my odd function. So I have to show if that's true. If that's true, then I know my function's even. So this is saying plug in a negative for x. So 5 over 2 minus negative x squared. Now, is that equal to whatever my function is? So I want to simplify this, and I want to show that that's the same. Well, negative x squared is positive x squared. So I get 5 over 2. That minus is still there. And so the question is that true? And it's yes. So I can conclude that my function is even. Now, the functions will never be even or odd at the same time. So if you know that it's even, then immediately you know that it can't be odd. And then if it doesn't work for both even and odd, then you know that it's neither. Now let's look at a picture of this. As you can see, if I said that this is my line of symmetry, the graph perfectly folds over that, which is why we would say that it's even. So if it's symmetric over the y-axis, it's going to be an even function. Let's look at another one. So we start with even. Is this statement true? So I plug in a negative in for x. So 5 times negative x over 2 minus negative x cubed. Does that equal 5x over 2 minus x cubed? Well, I get negative 5x over, because 5 times negative x. And then here, because it's cubed, I have 3 negatives times the 4th negative. So that's going to be 2 plus x cubed. Now, those are not even. Those are not the same. So even just looking at that, I can say that it's not even. So nope. So now we have to try if it's odd. So if it's odd, same idea, plug in a negative x. So that's 5 times negative x over 2 minus negative x cubed. So that's f of negative x. Does that equal a negative in front of my function? So that means negative 5x over 2 minus x cubed. So simplifying this, I get negative 5x over 2 plus x cubed again. And if I were to factor out a negative in the bottom, then I get a negative 2. So they're still not equal. They're still not the same. Nope, those are not the same. So therefore, it's also not odd. So it's neither. And if we look at the function here, I'll erase that so we could take a look. For it to be even, it has to be symmetric over the y-axis. Okay, that's clearly not. If I fold it over, it doesn't match. If it's odd, it's going to reflect and reflect. And that doesn't reflect and reflect. That doesn't reflect and reflect. It has to reflect over both. And it doesn't. They don't line up if you reflect over both. So that's why it's neither. Now for this next one, let's just look at this. So this one is actually going to be odd just by looking at the picture. And the reason is because that's going to reflect over and reflect over. This is going to reflect over and reflect over. They're symmetric. this reflects over and then reflects over, and it'll line up perfectly. So let's kind of show that. Let's show if it's actually odd. So f and negative x, does that equal negative f of x? So plug in negative x. Does that equal negative 5 over 2 minus x squared? Well, up here, I get negative 5x, negative x squared. That'll give me 2 minus x squared. And then here on top, I get negative 5x over 2 minus x squared. Those are the same. That's why we would say it's an odd function. So, what did we learn today? Well, we talked about even and odd functions and reflections when it comes to our parent graphs. So, the definition of an even or odd function, I'll just stick with the even. That is f of negative x equals f of x. Now, here, I'll do the odd too. Why not? Please, this is something that we just have to know. It's a flashcard thing. We got to know that this is an even and this is odd. It'll make future mathematics much easier, I promise. And then what does a negative in front of your function do? Reflection over the x-axis. This does conclude our lesson. If you have any other questions, please leave them in the comments.